Welcome to This Is My Architecture. I am Han, and today I am joined by Satish from Biopharma. Welcome.
Thank you, Han.
Right. So before we get into your architecture, can you tell me a little bit about Biopharma?
Yeah, our company is in the biopharma industry. We develop targeted personalized treatments in the area of neuro disorders. By neuro disorders, I mean diseases like Alzheimer's, schizophrenia, and Parkinson's.
So I see that you have a data lake. So once the data lake has been populated, how do you orchestrate and curate it?
Yeah, that's a great question. So once the data lake has all the data, we need to get the data to the processing layer. So the first thing what we do is for MRI data processing, which we are discussing right now for this architecture, we have the AWS batch service, which acts as orchestrator. So when we run a job with an AWS batch, it creates many EC2 instances. In this case, we are talking hundreds to few thousands of EC2 instances. Okay. So the compute layer is instantiated. And the compute layer requires a storage for which we are using FSX. And FSX is the one which obtains the data from the data lake in this case. So then this is enabled at the time of provisioning the FSX storage. At the time of provisioning, we have the capability to sync with a particular input S3 folder. And AWS batch orchestrates this download, and it reads the data. And this entire FSX storage is mounted onto an EC2 instance. This is where the processing happens, and the curation also happens during the time of processing.
So as a batch process, there must be a long processes that you may have quite a bit of errors. How do you manage that?
At the time of processing, definitely, this is a multi-day job for most of it. Depending upon the data sets, it can take anywhere from 24 days to 7 days. So at the time of processing, if errors happen, we identify it this way. We actually have AWS batch sending events into event bridge, even by notifying the change in status of AWS batch. That's one. These are the events that are communicated. Okay. These events are being sent by Lambda onto Elasticsearch, where they get indexed. That's how we get to know anything that's failing. We immediately get to know of the events through Elasticsearch.
Okay. So from the data science perspective, how do they visualize and consume the data sets?
Yeah. Our data scientists or biologists are the primary consumers of this pipeline. Okay. So how do they come to know us? We have all the logs being sent from AWS batch into Elasticsearch. That's one. They can actually look into the logs to see if they are more technical, they would like to know what all subjects have been processed. So that information is communicated again from AWS batch to Lambda. Lambda indexes. That's one. And the second thing is the output that's produced during the processing. The output that's produced is actually stored in FSX, which is again synced into data lake using an activity called a DRT, or a data repository task, which is provided by AWS. This automatically syncs terabytes of data that's produced on FSX back into the data lake. And this data is the one that contains all the required correlation matrices required for visualizing this data. So our biologists can look into the data lake to see the data.
Awesome. So it sounds like you're able to not only ingest and curate and orchestrate the data, you're able to handle the errors and process it where that the data scientists can visualize the data and also see the status from the long-running batch so that they can see the petabytes of data that you have for the MRI scans to help with that accelerated processing.
Exactly. So it all helps, all the things that we do is to help our biologists and data scientists take advantage of the pipeline. So they are going to trigger the pipeline, and they can monitor the entire pipeline with themselves, and also look at the visualizations that are also enabled by Elasticsearch, or the Kibana dashboards are being exposed to visualize, and we also have the data being visualized in our data warehouse that's powered by data lake.
So thank you so much for going over your architecture. That is amazing how you're able to help the data scientists not only visualize the data, but also help with that rapid, accelerated research and development for personalized neuro disease and also drug discovery as well. So thank you so much.
Thank you so much, Han.
And thank you for watching This Is My Architecture.